We have to find the center of mass of the uniform semicircular wire. Suppose this is the XY coordinate system on which we are representing the semicircular wire whose center is at the origin. Suppose M is the mass of the semicircular wire and R is the radius. Hence, its mass density is M by pi R. Pi R is the length of semicircle. It is the length of semicircle because for the whole circle, total circumference is 2 pi R and half of that is pi R. So this is the mass density. And this mass is distributed over the length, so it is a continuous mass distribution. Suppose there is a point A on the circumference which makes angle, this length OA, which is equal to radius of R, makes an angle theta with the x-axis, and coordinate of A is x and y, where x is the length or distance of A along the x-axis and y is the distance of A along the y-axis. We can write this x and y in terms of the polar coordinates using this triangle OA, and this is suppose B. In this triangle, we can write sine theta equal to perpendicular oblique hypotenuse, and perpendicular is y, so we can write it is y by r. This implies that y equal to r sine theta. Similarly, we can write cos theta. Cos theta is equal to base oblique hypotenuse, that base is x, hypotenuse is r, so x equal to r cos theta. Hence, we can also write this coordinate of point A as r cos theta and r sin theta. Now we take a elementary length at point A, dl, and this dl makes an angle d theta at the center. Using the formula angle equal to arc by radius, we can write d theta equal to dl by r. So dl is equal to r d theta. This is the elementary length. Hence, we can find the elementary mass dm. It is the mass of the elementary length dl. It is the product of mass density, this is m by pi r, and the length, that is dl. And dl we have found, this is r d theta. Therefore, we can write it is m by pi r into r d theta. R and r will cancel out. So dm is m by pi d theta. Now we use the formula of center of mass to find the coordinates of it. X center of mass is integral x dm by integral dm. Y center of mass is, this is the y coordinate of center of mass, it is y dm by dm. And z center of mass is integral z dm by dm. So we first find x coordinate of the center of mass. It is equal to integral x dm by integral dm. It is equal to. Now, we put the x coordinate or the distance x of the elementary length in this formula, that is x is r cos theta. So we write here r cos theta. It is the distance along the x-axis into dm. Mass of the elementary length is m by pi d theta divided by integral dm. Integral dm refers the total mass of the semicircle, and total mass is capital M. So we write simply it is as a m. Taking the constant term outside the integral, we will find r into m by pi integral cos theta d theta, and limit of integrations will be such that it covers all the length of the semicircular wire. For that, we start at theta equal to 0 along the positive x-axis and go to the over the length, and final is theta equal to pi along the negative x-axis. Therefore, theta is equal to 0 to pi. This is our limit of integration, and divided by capital M. This M and M will get cancelled. So it is R by pi integral 0 to pi cos theta d theta. Now in integration we have already known the formula that integral of cos theta d theta is equal to sin theta, and integral of sin theta d theta equal to minus cos theta. So using that this formula we can write it is R by pi, integral is sin theta, and now put the limit. First we will put the upper limit, it is sin pi, then minus, and then lower limit. This sin pi is 0 and sin 0 is 0. That means x center of mass of the semicircular wire is 0. Y coordinate of center of mass equal to integral y dm by integral dm. Here y is the y coordinate of elementary length, and it is y r sin theta. It is r sin theta into dm. dm is m by pi d theta divided by, and integral dm is the mass of the semicircular wire, so it is m. Taking the constant terms out, it will be r into m by 2 integral sin theta d theta divided by m, and limit of integrations are from 0 to pi. Common terms are cancelled out, so remaining is r by pi integral 0 to pi sin theta d theta. Integral of sin theta is minus cos theta, and limit of integrations are 0 to pi. We put the limits. First upper limit, it is minus cos pi, minus, and then minus cos 0. Cos pi is minus 1, cos 0 is 1. So it is equal to r by pi. This minus and minus becomes plus, so it is plus 1, minus, and cos 0 is 1, so it is minus 1. This minus and minus again become plus, so 1 plus 1, this is 2, that is 2r by pi. Hence, y center of mass is 2r by pi. And z center of mass, we can say it is 0 because no mass is along the z axis. That means distance of the elementary mass along the z axis is 0. Therefore, its coordinate of the center of mass along the z axis is 0. Hence, center of mass of semicircular wire is 0, 2r by pi, 0.